to talk to you about flow down gradients, a core concept in physiology. My name is Dr. Rebecca Borup. I teach human physiology at LECC. I've looked for videos about flow down gradients. There's a lot of them out there, but none that fit the way I want to teach it to my class. So I went ahead and made my own. So we'll start with kind of an everyday thing that we've all encountered in real life. We've all walked up hills, we've all walked down hills. Maybe as a child you rolled down a hill, maybe you rolled a ball down the hill, maybe you rode a sled down the hill. We're familiar with this idea. So here I have a hill, and if we look at this hill, we're going to call this a change in altitude. So we go from low altitude to high altitude here, relatively speaking. Okay. And you'll notice that the steepness of the slope on this side is much less than the steepness of the slope on this side, right? So if I give this ball a little bit of a nudge and push it in this direction, that ball will roll rapidly down the hill. And that should make sense to you. But for that ball to roll more rapidly, faster, we would need to give it a nudge in the other direction. So if we give it a little bit of a nudge this direction, it's going to roll down this hill, and the rate of its movement will be much faster going down the steeper side. So a steeper slope, in the language that we're going to be using in class, that represents a steeper gradient. And in this context, that gradient is an altitude gradient. Or more precisely, a change in altitude. So when we think about gradients, what I want you to think about is a change in blank over distance and here we've got the change that blank would be filled in with altitude. Low is faster on the steeper slide. Now let's go over to a different gradient. And again, you may have encountered something like this in real life. Let's imagine that this is, for example, compressed air in one of those containers you might use to dust off your keyboard on your computer. And the blue circles in there represent molecules of air, and they're all packed tightly into this canister. Well, as you likely know, if we were to open that canister or squeeze the trigger, so to speak, and give room for those molecules of air to move, they're going to move very rapidly out of the container where they are less compressed. So here we're going to say more compressed. So this is air, less compressed. And what I'm going to call this is a concentration gradient. The air is concentrated in the canister. It is less concentrated in the air outside of the canister. And as you likely know, if you've ever used one of these canisters and it starts to run out of compressed air, the flow of air gets weaker. So once again, the higher the gradient, the faster the flow. And in this case, what is the gradient we're talking about? If we go back to this idea of a gradient is a change in something over time, or I'm sorry, over distance. In this case, we're changing concentration. It's a difference in concentration between here and here, as you can likely see. This next example is going to represent just a simple pipe, if you will. When I was a kid, I haven't seen them in a long time, but we used to play with PVC pipes to make marshmallow guns. And the simplest PVC pipe was basically a blow dart. Not really a dart. Instead, we would shoot marshmallows. So if we're going to put up my little marshmallow right here, I guess it's purple today. Okay. And you load it into your little tube and then blow on it. And as you blow, what you're doing is you're essentially producing pressure. You're adding air pressure. And it turns out that the pressure closer to your mouth, of course, is going to be higher than the pressure over here, where we have the lower pressure. Relatively speaking, again. And so that would cause the marshmallow to shoot through the pipe out the other side. It worked really great. It was really fun for about 2 minutes before the marshmallow got soggy and your pipe became a sticky mess. But kids are kids. It was fun for us. The next type of gradient I want to talk about is we're going to call this an energy gradient. Now, this one's a little bit more abstract. So I'm using something we've probably all encountered, and let's say just we've got a campfire here. And so when you are camping, maybe it's a cold night, you're going to get closer to the fire. Maybe you're getting too hot, you're going to move farther away from the fire. And the reason for that is what we have in this fire is what I'm going to call heat energy. And the closer to the source of that energy, the greater that energy is. So here we would have a high amount of heat energy. As we move away from the fire, that energy dissipates into the atmosphere. And so over here, if we're standing a few feet away, we would have a lower amount of energy. And if we look at, if we could see the energy, and actually sometimes you can see that, you can kind of see how the air blurs a little bit closer to the fire. You're not really seeing the energy per se, you're seeing the effects of the energy, but we can at least feel that energy, right? In this case, we can feel the heat. And so we can feel that it is flowing, if you will, from a source of high heat to a source of lower, or to an area of lower heat. And so again, we have encountered another gradient. So going back here, what is this? Is this change in energy over distance, with the high amount of energy being here, a low amount of energy being here. The next example I'm going to talk about is a battery. So I've drawn here kind of a simple schematic of a 9-volt battery with the positive and negative sides of the battery here. And we don't really need to understand how that's exactly made, but essentially what it comes down to is the separation of charges. Positive charges are concentrated here, and negative charges are concentrated here, and they're separated by a barrier that they cannot cross. And so that barrier would be an insulator of some sort, or a barrier. And because they are separated, they're, I want to be a little careful with the words I'm using. I don't want to say necessarily unstable, but they're essentially in a high state of, well, they're attracted to one another. So attraction, if you could say, we've got an attraction gradient. And so these two molecules want to move, or these two charges want to move toward each other, but they can't because the insulator is in the way. But of course, if we connect these two with a wire of some sort, we plug them into some type of a device. I'm just going to draw a simple little light bulb here. So there's my little light bulb. What ends up happening is we get the flow of charge from one side to another. Now, with a battery, it's usually the negative charge that flows towards the positive charge. Now, we've all used batteries. We know that over time and with use, they essentially wear out. So what's happening is the gradient dissipates. It gets lesser. So when you get a brand new, fresh battery, we have a high, I'm going to call it an electrical gradient. At first, because we have a lot of these charges separated. But as the negative charges flows into the other side, it's going to start to cancel out some of those positive charges, and my gradient becomes progressively lower. And the ability to power a device like a flashlight, for example, becomes lesser. And so if you were to leave a flashlight on, you would notice that as the battery drains, the light bulb becomes dimmer and dimmer and dimmer. And that's, again, because what's happening here is the gradient is dissipating. And as the gradient becomes smaller and smaller and smaller, the amount of flow decreases. So as far as principles here to remember about flow, flow of anything, whether we're talking air or blood or electrical charges or heat or the movement of a ball, and I know balls don't really flow, but you can pretend. the movement of anything through the process of flow is always going to be a high blank to a low blank. So from high pressure to low pressure, from high energy to low energy, from high altitude to low altitude, from high concentration to low concentration. And the greater the gradient, the faster the flow. Now, we'll apply this frequently throughout the semester, and you're going to get into the habit of thinking in this concept and this terms, but that should get you a good starting point for what gradient actually means, what gradient flow means, what flow down gradient is.